I've heard quotes from Anthropic CEO saying that in the next 6 to 9 months, 90% of the code is written in with AI.
So when I hear like, oh, it's going to be, 90% of the code is going to be written by AI, I look at where we are now. I have a hard time imagining that in 12 months we're gonna be there. The biggest use case, surprisingly, that saves the most time wasn't code generation, but it was something like stack trace analysis.
If there's a CTO who can go out with trying to understand what engineering productivity then can implement in their organization.
So there's a quote, let me see, you reference it here about, comes from Mark Zuckerberg, which I have to have a kind of a blanket disclaimer. I'm not the biggest fan. He has sort of this it kind of went viral on LinkedIn clip that he was explaining what great product organizations do is that they can learn a lot faster. And so when we tie this all together and we think about what's the role of engineering, is...
What do you mean by engineering productivity in your own sense?
Engineering productivity isn't necessarily the presence of something, but it's the absence of friction. Engineering productivity is a product problem as well, because engineering's ability to execute is, in a lot of ways, dictating how fast your product organization can learn.
Can you explain what is product velocity and why is it very crucial for organizations?
Whoever can learn faster is going to win. And I can't disagree with that.
Are there any downsides of selecting speed that you've observed when organizations just focus on speed?
Imagine two people sitting in a canoe and those two people are facing the same direction and paddling. But as soon as you flip one person and have them face the other direction and they're paddling, both could be paddling as fast as they possibly can with all of their strength, but they're paddling against each other and their boat is just staying still in the water.
How does Code 4 address some of the challenges which other frameworks have?
Implementing metrics and then seeing that they are just collecting dust on the dashboard is probably the very first experience that many organizations have.
Can you maybe walk us through one or two examples or companies which you have seen have gotten really, really good results?
The time to I would like to start using Core 4 to make better decisions to I'm making better decisions with Core 4 can be as little as 2 weeks.
Hello, everybody. Welcome to our podcast, Everything Product. So we talk about technology, AI, and product here. So today we are super excited to have Laura Taco. So Laura is the CTO at DX. Hey, Laura. Hi. Welcome to the podcast.
Hey, good to be here.
Why don't you start with a very quick background of yourself, and then we'll dive into our topic today.
Yeah. So really nice to meet all of you listeners in listener space. I'm Laura Taco. I'm the CTO at DX. We are a software intelligence platform. So we help you get developer productivity metrics, help you improve productivity, help you measure things like, is AI really helping us deliver software faster? I started out as an individual contributor developer, just like a lot of people who are now engineering leaders did. My specialty was in infrastructure engineering, Docker, Kubernetes, distributed platforms. And after a while, I guess I just became more interested in why we were building what we were building instead of the very technical how, and trying to sort of force multiply my knowledge across teams and orgs. That led me into leadership. And I do have experience working pretty cross-functionally my whole career. I've always worked in those sort of product trio kind of situations. And I did lead product and development in a few of my kind of more senior leadership roles. So I really like the intersection of product and engineering, which I suppose we're going to get into a little bit today.
Yeah. So engineering productivity is a niche space, right? So, it's becoming popular in the last 4 to 5 years. A lot of people are talking about it, embracing it and all. So how did you end up in that space? And, could you talk about that story?
I think it's so interesting because the more that I think about it, I think I've always worked in developer productivity because I've always worked on developer tools since 2012 or 2011. I started working on infrastructure as a service, so like public cloud offerings. And when I think about it, really our whole point was to make developers more productive so that they could focus on building out their business logic and not worry about the infrastructure stuff. But I think you're right that the actual discipline of developer productivity metrics it's really gotten momentum in the last few years, specifically, as you called out. But when I was working at CloudBees, which if you've used Jenkins, CloudBees is a bit synonymous because that's sort of the home of the open source project, or a lot of people who contribute to Jenkins work at CloudBees. So I worked in CI/CD before that. We were acquired and came into CloudBees, and we thought, we have all of this data from all of these CI builds and CD jobs and all this stuff. Can we not figure out a way to take all this data and make it so that teams can see where the bottlenecks are in their delivery process and make it easier? Turned out that was really, really difficult. So we kind of took a swing at it when I was at CloudBees. And then later on, as I left my corporate world and I became an independent engineering leadership coach and consultant, the measurement part of developer productivity was just a crucial problem for a lot of the people I worked with. So that's what led me down to a lot more research and inevitably sort of led me to working at DX, where we get to work with some of the biggest companies in the world, helping them define what productivity is, measure it, improve it. It's very rewarding.
Awesome. So now we know that you are the expert in this space. So we'll get into more details about engineering productivity. So when I talk to people about engineering productivity, right? So I think most of the people I find are either like engineering productivity is more on the lines of like the number of PRs engineers submit, or people are very deep into what engineering productivity is, but I've not seen people who are in the middle. So people are either understand it completely or don't understand it, is what I found. And I'm thinking maybe out of this podcast, if there's a CTO who can go out with trying to understand what engineering productivity is and can implement in their organization, or an engineering leader can look at some of these metrics to make their teams better, or even a developer, right, could go in and understand what does velocity, product velocity, or engineering productivity or experience mean, right? So that'll be great if we can get that out of this podcast. And the hope is like, why don't we just start with what do you mean by engineering productivity in your own sense?
Yeah, I think I would love to speak to all of those engineering leaders that are listening, but I would love to speak to the product leaders who are listening specifically, because I think as you pointed out, there's a variety of depth of understanding of this problem, but usually it's lying on the engineering side. But truly, engineering productivity is a product problem as well, because engineering's ability to execute is in a lot of ways dictating how fast your product organization can learn and understand what your users need. And in terms of my own definition of engineering productivity, one thing I'm trying to do that actually I had a great discussion with Kristen Foster Marks, who's a developer experience researcher. I'm trying to, we're trying to align the industry on one definition. And it turns out that's really, really complicated. So when we talk about product velocity, we have all these, individual people with their own definitions. And one of my, I think, most consistent definitions and ways that I can explain it to make it easier for everyone to understand is that engineering productivity isn't necessarily the presence of something, but it's the absence of friction. And so to make your teams more productive, we're not talking about necessarily adding things, but we're talking about taking away the friction. And to do that, we need to understand where the friction is, how big the friction is, how much the friction costs, so that we can work from there and figure out how to remove it, so that engineers and really your whole product development lifecycle can be as frictionless as possible, so that you can go from idea to execution to getting it in front of your users and learning as fast as possible.
Okay. And is there one metric that you can measure engineering productivity with, or is it a group of metrics?
There is definitely not a single metric.
Okay.
And this is really challenging because we have product North Star metrics or metric, and we try to sort of distill performance down to one number. We do it with revenue on the go-to-market side. We might have a single North Star metric on the product side, but engineering is a lot more complex because we're always one step removed. We're one step removed from the North Star. We're one step removed from the revenue. And so the one metric that matters for engineering just doesn't exist. And there's actually a lot of harm that can come from trying to chase down just PR throughput or just quality, because we lose sight of a lot of other things. So the Core 4 framework, which is a framework that I'm co-author of, kind of takes the body of research that we have available to us right now and just makes it easy for product development teams, engineering leaders, executives to implement a lot of these strategies, methodologies, theories in their own organization, start measuring so that you can start improving and removing that friction.
Yeah, and that's a very good way of putting things, because I've seen a lot of times when product people are in the engineering productivity space, right? When you define metrics for products, it's always one North Star and, supporting metrics and so on and so forth. But the problem with engineering productivity is it's so holistic and complex that you can't measure it with just one metrics. And if you try chasing that one metrics, you don't get the holistic view of what developer experiences, right? Yeah. And as you mentioned core 4, right? Let's maybe dig deep into the article and also why don't you get into more details about can you explain what is product velocity and why is it very crucial for organizations?
Yeah, let's start with product velocity. So, developer productivity is a nice term that, resonates with some audiences. It doesn't resonate with other audiences. I think zooming out, at least for me on the executive level, what I and what a lot of the other, senior leaders that I work with are in search of isn't necessarily just that engineering can ship faster. I mean, that's great. That's one of the components. But what we're really after is cutting down time to market so that we can get value from idea into users' hands, validate that it's the right thing, have shorter feedback loops when it comes to iteration, experimentation, rapid learning. There's a quote, let me see, you reference it here about, comes from Mark Zuckerberg, which I have to have a kind of a blanket disclaimer. I'm not the biggest fan, but even a broken clock is right twice a day, right? So, he has sort of this famous, it kind of went viral on LinkedIn clip that he was explaining about like what's product strategy at Meta. And he kind of said like, well, it's just whoever can learn faster is going to win. And I can't disagree with that. I mean, I think that is really essentially what great product organizations do is that they can learn a lot faster. And so when we tie this all together and we think about what's the role of engineering, the role of engineering is to spend as much time on innovation as we can. And that means that we need a stable infrastructure. We need high reliability. We need things that are easy to change, that the cost of change is relatively low. We need fewer incidents. And when incidents do happen, we need them to be resolved faster. What I'm describing now, if you were an engineering person, you would say, oh, that's the absence of tech debt, or that's the absence of friction. And so that's sort of the system, what we're aiming for. When I talk about product velocity, I'm talking about a system in which engineering and product are working together to get value from idea to user very, very quickly, validate hypotheses, run experiments, and ultimately, find the gold that's buried out there for your users, so that your users can continue to get more value from your products.
Yeah, and often you see teams producing a lot more, but how do teams ensure that they're moving in the right direction? So any insights there?
Mm-hmm. Aligning product and engineering, I think, is a problem as old as time, right?
Yeah.
I think there's classical conflict there. It's kind of like it's a bit of a trope, right? About, oh, product manager wants this shiny new thing and engineering team wants to do this thing. And like, there should be a healthy tension. There should be a healthy tension between product and engineering, because ultimately there are different objectives or different ways of measuring success, slightly, subtly. Really depends on the organization. But when engineering and product fail to kind of connect on how removing friction from the development process actually helps users, that's when things start to get really, really difficult. So I've found it in my previous roles difficult to have conversations with my product counterpart about why we wanted to do this, quote unquote tech debt project, because it was difficult to articulate it in terms of user benefit, or it was difficult to articulate it in terms of business value. And so then when we have something that's just very amorphous, and basically engineering's answer as well, just trust us, we're in the code base every day, let us do, you're laughing because you've heard this before, right? Just trust us. And then you have a customer facing feature that has revenue potential of, X, whatever. It's really difficult to prioritize those things because it's not even like apples to oranges. We're trying to compare like a bird to something like an orange. It's just like they're totally different classes. Um, and so what the core four aims to do, and a lot of the work that I've done with clients, with DX customers, is trying to bring engineering and product together to unite on, first of all, product velocity being the thing that we're after. And then when we can figure out how to measure if we have it or not and understand how to improve it, it makes those conversations just much easier because now we have a common language that's focused and looking at the business instead of it being, well, engineering wants to do their tech debt stuff because we should just trust them, and product is always trying to get another customer facing feature in, and we just have sort of a stalemate.
Okay. Yeah, and the reason why I was laughing is like I was in an organization which was a lot sales driven. So every time there was a very big B2B offering that was sold, the engineering had to create a different version of the software, and it became so difficult to maintain the software. End of the day, it was biting the customers because changes were taking so long and so on and so forth. That's where I was like, I could absolutely relate to what you're saying, as unless there's a balance between both of them, you're always trying to fight with each other, right? And one other thing, right, now that we have talked about what's the right direction, we talked about what speed is, right? So are there any downsides of selecting speed that you've observed when organizations just focus on speed?
So velocity is not just speed, it's speed and a direction. And one of the common things that I see happen is that when we get preoccupied with speed, we kind of lose sight of the direction. And so you can imagine two people sitting in a canoe, and in one version of reality, those two people are facing the same direction and paddling. And they're obviously moving in whatever direction they're paddling. But as soon as you flip one person and have them face the other direction and they're paddling, both could be paddling as fast as they possibly can with all of their strength. But they're paddling against each other and their boat is just staying still in the water. And I can't tell you how many personal experiences I have, and I'm sure you've had personal experiences as well, where organizations work that way. We have, team X doing this and team Y doing this, and they're completely not pointing at the same direction. And if we would have just adjusted something, maybe we could have gotten more momentum, more velocity. Or we have, product and engineering just simply not aligned on where they should be headed, and they're constantly pulling against each other instead of putting that effort into the same direction and moving. And so speed is important, but it is only one part of it, because you could see an organization that really focuses on speed but sacrifices quality. That's actually not going to bring you much. You're not going to be far ahead. Or we're focusing on speed, but all we're doing is just maintenance work and chores and keeping the lights on. We're not actually doing innovation. That's not bringing anything new to your customers. It's just maintaining the table stakes kind of baseline product experience. That's also not bringing anything. And so we need speed, but we also need to balance it with other things in order to make sure that we're actually providing a net benefit to the business.
So that's where you have the core four. You have all of these supporting metrics which support speed. So I want to get into the core four framework, but before I get into that, right, I know I tried talking to a lot of other engineering leaders within different organizations, and just I was doing some research before this podcast, right? So whenever I ask people about engineering productivity, I kind of hear a same repetitive story, which is we have tried Dora, or we have tried Space. We had this flashy dashboard in our company, and we basically publicized it in a engineering COP and so on and so forth. But the problem is it's all good the first 2 months, and the second is people don't start following it or implementing. So essentially you have a framework, you start measuring these metrics, but they're not actionable. We haven't seen any tangible outcomes. So I think that has been a problem in the engineering productivity space where people start measuring, but they have not seen an output. So they stop measuring it again, and they're again skeptical about new frameworks that keep coming up. And the second thing which I've seen is there are so many of these frameworks. People either implement it completely or implement a part of it to get the output desires they want to do. I want to know about like what has your experience been, right? Like, have you seen instances like this before, and how does Code 4 address some of the challenges which other frameworks have?
Implementing metrics and then seeing that they are just collecting dust on the dashboard is probably the very first experience that many organizations have with developer productivity metrics. And not because they're wrong or uneducated. It's just this is such a it's a complex space to operate in. And I think one of the main reasons is that we see data drivenness as something that's very linear. So you can imagine the null kind of spot. We're starting at 0. We don't have developer productivity metrics. We know that there's bottlenecks in our software delivery lifecycle, and we're trying to figure out where they are. Well, when we become data-driven, now we have metrics, we have dashboards, and we know where the bottlenecks are, and we can make better decisions. And it's not quite so simple as going from 0 to 1 in a straight line, because this actually operates on different axes. We often think about data infrastructure as the thing that's going to get us from 0 to 1 in terms of data drivenness. So in a world where we have no data infrastructure, it means we don't have access to DORA metrics. We're not tracking anything. We don't know, we're in the dark when it comes to any of the measurements. And then when we have a lot of data infrastructure, that means we have access to all the data. But that's actually only one of the axes. We have also data literacy that's extremely important. And so the reason that many organizations fail in the ways that you've just explained is that they've boosted their data infrastructure, but not done anything for their data literacy. So now what we have is a lot of data infrastructure, but individuals who still have low data literacy and don't actually know how to use the metrics. Because before we care about things like cycle time or PR throughput or any of those measurements, we have to understand, well, what does it what does it actually look like, feel like? What do you do to look at data, interpret it, make a hypothesis, do something, measure the outcome of the thing that you just did, and then start the process over again? It's a product mindset. And I find that actually one predictor of success for organizations that do very well with developer productivity metrics are organizations that have that cycle in their product organization, and their product managers are actually practicing that, because there's a lot of transferable knowledge that we can kind of extract from product managers who can sort of lead the way when it comes to data literacy. When I say this, some people roll their eyes at me because they think, well, what can a product manager teach me about data? I'm the engineer. But it's not about data infrastructure. It's about data literacy, and those two things are really distinct skills. And product managers often are extremely data literate folks, because you're looking at how users are using your product and making decisions based on that data, or at least, in theory, we would like to we'd like to all be doing that. I know that doesn't happen always in real life. But yeah, the kind of the failure patterns you've described are absolutely normal and kind of part of the growing process. Doesn't have to be, but definitely part of the learning process.
Yeah, and I think the data literacy is the problem, because a lot of times you see that there is one platform organization or an engineering productivity organization who is defining the metrics, measuring the metrics. But when it comes to frontline, right, like, which is who is going to take action on these metrics, that's either engineering managers or the product partner who is part of the product, who is saying that, okay, let's look at these metrics and see how we are at, and can we improve the overall velocity, which again helps us give that value to the end user much faster, right? So I think, so you're saying that evangelizing that, making them understand what it is, would be a way to make these metrics actionable? Or do you think it we should get to a point where it is prescribed that people are given actions on what they need to do to improve this? What's your take on that?
Yeah, I would love for a world to exist where we have metrics. And I mean, we're getting closer here. I think this is one of the things that AI is actually a really good solution for, or at least part of a solution, is ingesting a whole bunch of data and pointing out places that perhaps, it's just faster for a robot to do it than for a human being to do it, to find out, point out different correlations, see different, phases of, we introduced this particular change and look what happened in 3 months, connect the dots, so to speak. The reality is we're not quite there yet, realistically. And so there still needs to be some, there's always going to have to be human interpretation. And we're never going to get just a set of instructions about like, do A, B, C, D. I would love to listen to this podcast in 5 years and realize how wrong I am. That would be amazing. So let's see. But yeah, I think just like any other developer tool, product, engineering leaders who are now using developer productivity metrics or being expected to use them in order to improve performance need support and training on how to do that. It's not a, if you build it, they will come scenario. I mean, no product really ever is. And I do think that thinking about metrics as a product is one of the key mindset shifts to have. You are building a product for your users, which are engineering managers. What pain do they have? What are the jobs to be done? How are they going to use this? How can you get their attention? They're obviously not going to pay for it, but they're paying with their usage and their attention. It has to solve a real problem for them. Otherwise, as you said, they're going to look at it for 2 months and then never touch it again because it doesn't, the loop doesn't close for them.
Yeah, and always it's I keep hearing this answer that we are very busy, we have deliverables that we have to get done, so we don't have time for this. So in this at least like, how do you, like, who is the champion who is going to get us there in a team? So is it the engineering leader, is it product leader, or is it both of them within the team who can bring in change looking at this?
Mm-hmm. Oftentimes the size of the company will depend. Oftentimes for very big companies, executive sponsorship is really important, but it's rarely in those situations, a CTO or even a VP of engineering that's necessarily saying, oh, this is what we want. They're going to delegate that decision. So there's a couple different ways that these metrics really gain steam. One is from a champion who has some sphere of influence, of direct authority. And I think that one of the best things to do if you're a person like that and you're looking to get some buy-in, some momentum, is finding a cross-functional ally. And usually that's a product manager. So I always say, find a product manager and then find a technical individual contributor that can speak to the technical feasibility of the data ingestion and all the stuff. And the three of you together have a lot of authority on not only is how feasible is this to get the data, to organize it, if you're buying a tool, building something to start with, whatever that is, but also you have authority on what was it actually going to look like to roll out this into our decision-making process, because it does have to be incorporated in the decision-making process. It can't be something that's totally separate.
Right. Yeah. And yeah, I think sometimes I've also seen that when you tie these to OKRs and all, it's more effective when people actually consider taking action looking at these metrics. So yeah, I think that's a good point. So let's dive into the core 4 framework now, right? So can you walk us through what core 4 means? Like, why is it just core 4, and more details from that?
Yeah. So we have DORA metrics, which are now a decade plus old. There's a lot of DORA metrics actually, and there's a lot that DORA does. But when I say DORA metrics, usually what people think about are those 4 key metrics that measure software delivery capability. Those were, a decade plus on the scene, very helpful. A lot of organizations were using them. Then we had the SPACE framework, which you mentioned earlier in the episode. This is not a prescriptive list of metrics, but more of a framework to describe the 5 dimensions of productivity and to make sure that you don't have any gaps in your own understanding of what it is. And then a little bit later came the DevX framework, which is a bit more focused on engineering teams. It's focused on cognitive load, flow state, and feedback loops as the 3 components to a great developer experience, which is correlated to better organizational outcomes. Huge bodies of research, decade plus, And still, every single day, I got asked the question, what should I actually measure? Because even though we have all this, all this great research, it's still incredibly difficult and overwhelming for someone who's a CTO or a VP or a platform engineering leader or a platform engineering product owner or product leader, which is often the case, to take all of that and distill it into, okay, here are the 12 things or the 16 things that we're going to put on a dashboard, because they just simply don't have time for that or the expertise. And so they're looking for guidance. And so Core 4 was really born from that question of like, okay, but what should I measure? And we wanted to simplify and unify the frameworks together and provide some very prescriptive guidance on what to measure that was backed by research, but also proven in the field. And so we got to work with some constellations of metrics, interviewing companies, figuring out which ones are actually driving decisions, which ones are actually helping them have better conversations at the board level, at the engineering organization level. And Core 4 is what we landed with. And it is 4 because we wanted to keep it very simple, easy to deploy. You can deploy Core 4 completely on your own, do it yourself if you want. Of course, it's also featured in DX heavily, our tool. And, it comes with peer benchmarks as well, but it's really designed to unify and simplify those frameworks, tie it back to the business, give leaders common language so that they can figure out what is causing friction and then make a plan and then measure the impact of executing the plan to improve developer productivity and experience.
Awesome. And I also like the way where you have like qualitative and quantitative data part of it. So a lot of times when people measure engineering productivity, it's a lot of time it's just quantitative but not qualitative. But can you maybe like, for anybody who's little at least like I don't want to spend time doing surveys and all, I have metrics, let me just look at the quantitative metrics, like what is your answer to them? Like why is it a really, really good combination? Because I like that and I do that my products too, but I want to hear it from you.
Yeah, I think it's a very fair thing to be skeptical about, especially because we've had perhaps poor experiences with employee engagement surveys before. It's where, it's just not, the quality and the accuracy has left something to be desired. That's fair. Qualitative feedback when it comes to developer experience is crucial to understand how impactful the friction is, and then also how frequently it happens. Because here's a comment, this actually happened on one of my teams. So I was working on a team where our PR review, like if we got our PRs reviewed in like 2 days, it was fine. And then I was working on another team where they were getting reviewed in like 6 hours. And I was like, whoa, this is really fast. But then we were having an offsite, and I was a manager at this point, and one of the team members was like, man, PR review is the biggest thing holding me back. It is so frustrating. It interrupts my concentration. I feel like I'm waiting so long. I think if we just committed to reviewing PRs quicker, we would be so much faster. And I was like, what? This is so fast, because my personal experience was that this is fast. It felt fast to me, but it didn't feel fast to any of them. And this is the complexity about developer experience and developer productivity. We're trying to remove friction. And so if your team tells you this has friction, you need to believe them, because why would they lie to you about this? Truly, we're all professionals and adults here. We can't get that information only from the quantitative data. And so we need to have the self-reported data to correlate with the quantitative data to figure out what is actually holding our team back, so that we can have some more information in order to prioritize what we do first.
Awesome. So that's where I think I know, even in this the speed metrics inside Core 4, right? You have the perceived rate of delivery. So essentially that means that 2 hours might be good for a person, but that could be bad for the developer, right? And so on and so forth. Actually, you're trying to understand what are developers feeling and then basically attribute that towards the overall productivity. Awesome. Yeah.
Yeah.
And I also want to understand, right? Like PR throughput is controversial, right? A lot of times developers don't like that. Like, could you explain like why you included it and how teams should properly use it?
Yeah, PR throughput was definitely contentious discussion, even among the authors. We weren't sure, if you can even find conference talks from myself and definitely from Abhi, who's the co-founder of TX, totally bashing that metric and saying, don't use this, never use this, it's a bad metric. And it is a bad metric when you use it to measure performance of individuals. Do not do that, don't recommend it. But when you use it as a system health metric to give you signal on whether developers can get work through the system, it is a really, really helpful metric. And in order to do that, it needs to be, of course, anonymous and also aggregated. And at team level is really the lowest kind of finest granularity you would want to look at it, just to avoid the bad danger zone of, stack ranking developers by PRs and these other kind of anti-patterns or bad patterns that tend to, rightly so, make engineers a bit apprehensive, skeptical about this whole thing. It's worth noting as well, GitHub just released their own guidance on how to measure developer productivity last week, late in the week. And PRs per engineer is also on their list. And so this is not just, PRs per engineer as a system level health metric is really useful. And what we ultimately decided on was that the utility of it, when used properly, is so good that we're willing to accept the risks with a population we believe can be adequately supported and educated on how to use it appropriately with appropriate guardrails. And so that's why that got in there. But again, speed is just one of the 4 dimensions. So we're looking at speed and PR throughput. We have effectiveness, which is a developer qualitative developer experience index. We have quality measured by change failure rate, and then innovation ratio, which is how much time you're spending on new features. With Core 4, it's really critical to look at those 4 numbers together and not just in isolation. So looking at PR throughput by itself doesn't really mean anything. But if you look at PR throughput with everything else, it tells you a much deeper, richer story about the health of the organization, velocity, figuring out, is the system full of friction, or are we doing pretty okay?
And at what level are you measuring core for? Is it more team against their previous performance, or one team against other team, or at the organization level? Because the reason why I ask is, right, teams are different, right? So platform teams have different velocity compared to product teams, compared to, a different kind of team. So what are your thoughts there?
Yeah. Internal benchmarking is probably the most effective way to use Core 4 or any developer productivity metric. So collect a baseline and truly yesterday do that. Core 4 was specifically designed to be able to be deployed with survey and self-reported data only. And this is also another interesting feature of Core 4. We wanted to do it that way because we noticed how many organizations were losing months of time, not like weeks, but like months, even year plus time, trying to instrument all of their data for automated collection with the quantitative metrics coming from their workflow tools. That's so much time. There could have been so much progress made in that time, when actually we have access to the quantitative data, and then we have access to the survey reported data. So if you ask a developer, on average, say in the last month, how many PRs did you close each week? It's not really that far off. And I think there's a big concern that, developers are going to inflate the numbers, or they're going to be not very reliable, which is no doubt, there's certainly isolated cases of that, right? Or we have recency bias. A good survey with good design can work around some of those phenomenon. DORA, which is often seen as sort of the canon for quantitative metrics, is their whole research and analysis is survey-based as well. The DORA, like the researchers behind DORA, don't have access to GitHub or Jira for the data that they're using to, produce their state of DevOps report. It's coming from a survey. And so we can use those same methodologies. In fact, many of them are written, the questions we have kind of overlapping research teams, with survey questions written in a way to get that self-reported data, so that it's not a question of months, but really weeks to get the baseline measurement and then start doing interventions so that you can measure against yourself. So that's definitely I think the most common way, absolutely recommended in every case to do that internal benchmarking. When it comes to comparing team to team, as you said, every team is different. And so When we're doing it to say, oh, your team is bad and your team is good, that's not very healthy. When we do it to like, wow, this team is really good at documentation. I wonder what they're doing. Could they help this team that's not doing well in documentation? I think that's fine. I think there has to be a tremendous level of trust in an organization to operate that way, right? And I recognize that not every person is working in an organizational context like that. Yeah.
Awesome. Yeah, and I have a question regarding like the benchmarking. So there is a benchmarking survey which you put out, which I think encompasses data of 600 different organizations, right? And you're saying for organization, if you're an organization who's trying to implement Core 4, you start with a baseline for your organization. So you compare the results of the framework with the benchmark, or like how do you take the benchmark with the baseline?
Yeah. So the scenario that I was talking about before are like, right, two individual teams within your organization trying to compare them to see who's better. That's not a great way to use, I think, really any data. When it comes to peer benchmarking or industry benchmarking, this can be really valuable on a strategic level to make sure that you're making the right investments. So on the organization level, if you see that overall your organization is spending 45% of time on new stuff, and you look at your industry 75th percentile and say, wow, other organizations at our size and in our sector are spending 60% of time on new stuff. We notice also that their developer experience is 10 points higher than ours. Perhaps this is a signal that you've been under investing on developer experience, and you need to do some strategic investment on improving developer experience on an organizational level. Obviously, there's a lot of work to do to figure out what exactly that has to do, what has to be done. But the external benchmarks are good at gap analysis, so figuring out where are we missing the mark, but also the opposite, which is protecting where you are doing really well. Because a lot of cases you might say, oh, well, it looks like we're fine on quality, so let's move some of the budget that we had for, whatever quality initiatives, let's move it over to XYZ. Well, if we do that, we can expect that that number is going to drop because we're not protecting our strategic advantage that we have with being extremely high quality. And so we need to think about the benchmarks kind of higher level, more strategic as ways to direct the flow of money, I think is probably the easiest way that I could put it.
So both of them have different signals, right? One could be more leadership strategic, the second could be more at a team level. Makes sense.
Yeah.
Yeah, and maybe I'll put this hat on of a CTO, right? I'm a company of a CTO, and if I want to implement Core 4 in my organization, I think the first thing which I would want to know is, right, like how much time typically organizations take to start implementing and see results, because 6 months, 1 year, what have you seen in your experience? And can you maybe walk us through one or two examples, or companies which you have seen have gotten really, really good results, because I want to know what the ROI is.
Yeah, so truly the time to I would like to start using Core 4 to make better decisions to I'm making better decisions with Core 4 can be as little as 2 weeks. And very much on purpose, we designed this to be something that you can rapidly deploy using self-reported data. So what we find is that companies that are using Core 4, what they can do is get that baseline information, and then immediately they have more data to make different decisions. And that decision making can happen immediately. Obviously not in every single case. It's going to be that quick, but we have definitely seen it take, we're more of a days and weeks kind of company and not a months and years kind of company. Obviously a lot of things are strategic and for the long haul, and those do take years. But when it comes to getting something out there, starting small, validating that it's useful for your organization, that's a question of weeks.
So you're saying that we need not implement each and every metric inside Core 4, but you start with a small set of metrics and then I iterate from there. Is that what you're saying?
So start with the key metrics. So Core 4 is there's a set of key metrics. So for speed, that's PR throughput. For effectiveness, that's the developer experience index, which I've created a kind of lighter weight, more easy to calculate 10 10 factor version of the DXI, which we can link in the show notes here because we've published that. Change failure rate, and then the innovation ratio for business impact. Start with those 4, and that's going to give some really strong directional signal in terms of what's being perhaps underinvested in, where you need to make more investment to reduce friction, improve velocity, and ultimately make sure that your engineering organization is prepared for, getting stuff in front of users as fast as possible.
So starting with the core 4 would be a good MVP to start with. Okay, makes sense. Yeah.
Yeah.
I want to get into the last segment of the podcast. So AI all over the place, right? So every time you open LinkedIn up, there's some news on AI, a new tool that a company is coming up, or a new adaptation which a company is doing, and so on and so forth. So, and AI is basically affecting engineering productivity a lot. So I've heard quotes from Anthropic CEO saying that in the next 6 to 9 months, 90% of the code is written with AI. And even Mark in a podcast like a couple of weeks back was saying 12 to 18 months, most of the software at Meta would be written with AI. Like, what do you think about productivity when AI is kind of writing all of the code? And I've also talked to, or at least listened to podcasts where founders, like a founder of Devin was saying that Devin is doing 25% of the code check-ins now. Like, it's not a human actually doing that check-ins. So how do you see productivity in terms of AI?
Yeah, I am optimistic, but I wouldn't call myself as bullish as a lot of those statements. So when I hear like, oh, it's going to be, 90% of the code is going to be written by AI, I look at where we are now, which is that sure, for a side project or for something that doesn't have to go through enterprise compliance, governance, secure software supply chain, all of these other checks, sure, like great, great. But operating in a complex enterprise environment, I have a hard time imagining that in 12 months we're gonna be there. The problems that I'm seeing right now in those organizations are engineers don't use the tools because they're not sure if they're even allowed to use them. I would say that's a very common use case in large enterprises. So I think it just, those claims I'm sure are true for a subset of companies and a subset of projects and products, but applying them globally to software development in general, I think it's a bit too far for me. Again, I'd love to listen to this in 24 months and be like, wow, I was really wrong. Things moved way faster than I thought. But you're right, AI does impact developer productivity in huge ways. We see, not even everything's going to be written by AI, but we see claims of 10x productivity boosts and a lot of these things. And a big question that engineering organizations are asking is like, where and how, and is that actually happening? And that's where, Core 4 can be really beneficial. And we do have engineering organizations who partner with DX, use Core 4 as a way to measure the impact that AI is having. So we get a baseline before they introduce tools or before they perhaps do a training and support campaign around, okay, here's how you can, you have access to Copilot, or here's a prompting workshop for you so that you can understand how to do recursive prompting or better mid-loop code generation or whatever it might need to be. And then you can measure the impacts of that. Oh, actually, we introduced Copilot and our PR throughput went up. Or actually what is happening sometimes, our PR throughput went down because now it's way easier to write more code at once. And so we're not breaking up things and our batch size is getting bigger. And our change failure rate is going up as a result of it, which is what, Dora has been studying the impact of AI a lot. And they found some really interesting results when it comes to the use of AI and organizational outcomes, particularly the hypothesis is around batch size. So the more data you have about your performance before introducing AI, the better you can validate and show the productivity improvements after AI. But you're right, it's a paradigm shift. So
yeah, that's right. And I think even if we think AI has significant impact at creating PRs and so on and so forth, change failure rate is still relevant, right? Even ROI is still relevant. Are you spending in the right space is still relevant? And I think tech debt is real, right? So when you use these AI systems, it's that how much tech debt are you accumulating as you're building bigger and bigger systems, and also when you're building software in bigger organizations, you have like 30 different touch points you have to go through to go from that idea to production. So it's not easy to integrate all of these things. So I think all of these metrics will still be relevant even if AI is doing a lot of this stuff. So
Yeah, they absolutely are. Absolutely are still relevant. And I think one thing that's a little bit tricky is that I've not met an engineer who wants to spend less time writing code that's enjoyable to write, but all engineers want to spend less time doing toil work. And we haven't really applied AI to the kinds of work that we don't enjoy doing. And it's leading to some interesting results, right? Because if AI helps us code faster, that's the part of our job that we like because it's creative, it's rewarding, and then we still have all the other stuff left over. It's not as fun. But we just released a report. Actually, we studied 180 different companies that are using AI really effectively and looked at what their engineers are specifically doing. And the biggest use case, surprisingly, that saves the most time wasn't code generation, but it was something like stack trace analysis, for example. So using AI to just shorten the loop on some of those tasks that were very complex and taking a long time, that was a huge time saver. And I think we're going to continue to see more problems being solved outside of code generation. That's actually going to help improve the quality of life for developers and improve productivity at the same time.
awesome. Yeah, let's go to the last question of the episode. So what's one piece of advice you would give to an engineering leader who's wanting to improve team's velocity?
An experimental mindset is the most important thing. We're not going to have a dashboard and answers jumping out at you. You're still going to have to interpret the data, and coming to the data with curiosity and an experimental mindset is going to help you identify areas for experimentation, make a hypothesis, take the action, measure the result, and then figure out, did that work or did that not work? The shorter that you can make those experiments, the better, and the faster that you can learn. So stay curious, be experimental, learn quickly, and you'll be on your way to being data-driven and improving product velocity.
Yeah. And so for anybody who has questions about Core 4 or wants to reach out, where can they find you?
Find me on LinkedIn. I think I'm the only Laura Taco in existence. So find me there. Shoot me a message. I love talking about this stuff. So happy to connect with you there.
Awesome. And for anybody who's listening, right, we'll mention all of the links to the articles that we talked about in the show notes. Please check out Laura Taco and also send her a message if you like this talk. Awesome. Yeah, thanks a lot for being on the podcast, Laura.
Yeah, thanks so much for having me.